Hi grade 12s, welcome to my channel. Let us look at this paper and review it in its entirety, hoping that you will see where you scored marks and where you lost marks and why. Otherwise, this is the November 2025 Maths Paper 2. Okay, let's have a look at the instructions. Of course, I'm going to single out the most important, but the others are not to be ignored. Key is that anything that we've used to determine the answers, we need to show, okay? And then the issue of rounding off, we either do 2 decimal places or nothing, okay? Right. So let's get to question 1, which is statistics. And take it down quickly, fast and furious. All right, there were 11 cars of the same model for sale at a car dealership. The age in years, okay, of each car and its corresponding selling price in rands is provided in the table below. So we've got our univariate data here. So obviously the number of years of the car will determine its selling price. So obviously this should be X, this should be Y. See, I like it when we really don't seem to have much. Okay. Now, first question, we need the line of the best fit or the least squares regression line. Okay, let's get to business. So we go to mode, we take statistics, and then we take that 2-column table, then we just input the things. So 2, 3, 3, 4, 4, 4. Let me see. Okay, so, and then we've got 6, 6, 7, 7, 8. So I've got 11 entries. So that looks okay. But again, please double check, folks, that all the inputs are correct. So I've got 293,000, 265,000, 256,000, 219,000, 241, Scordo, 246, Scordo, 226, Scordos, 176, Scordo, 154, Scordos, 180, Decent, 148 Scordos as well. Right, so we've got all 11 entries. We hit our AC button, shift number 1, regression A. So let's see, our A value comes up as 331,397, 20 to 2 decimal places. B, we repeat the process, shift 1, regression, and option 2 gives us -2, 2, 9, 8, 8, 3, 2 to 2 decimal places. So we know that our Y with a cap, remember this one is a Y with a cap, or whatever that is, it's not just Y. -2, 2, 9, 8, 8, 3, 2, X. Okay, so that's the least squares regression line that we get. Nice and easy. Let's go to 1.2. 1.2 says predict a selling price. Can you see? Exactly, we made the right choice there. So we've got Y equals 331,397 20 minus 22988,32x. So this implies that our y is 331,397,20 minus 22988,32. And of course, if this is 5, we put a 5 in there. So that would be the selling price that we need to predict. Okay, so we can go for it. 397,20 minus 22988,32 into 5. So we get a value of 216,455 rand 60 cents. Remember, the calculator will give you one decimal place, but the instructions are clear. We give 2 decimal places or none. Okay, so very important, folks. Of course, you can round off to the nearest, whatever that is. But at this stage, we just leave it as it came out. So what is important? Substitution and our answer, hoping that we have given it in the correct manner. Now we use the correlation coefficient. Well, this question, I hate it when they ask it like this, but maybe I'm the one who doesn't understand. Okay. Because it says use the correlation coefficient to show whether the prediction made is valid or not. For me, the issue of validity is besides the point here. If I know what I'm trying to say, for me, for this to be valid, it has to be a prediction within the domain. That's what gives the validity. But the strength of that validity or conviction is what comes from the correlation coefficient. I don't think the correlation coefficient alone is good enough to say if it is good, then any prediction you've made is good. For me, it doesn't make sense at all. So I don't know if anyone thinks about this, but yes, whatever. So let's look at what R is. Shift, number 1, regression, we check R. Okay, R here is equal to minus 0.95 to 2 decimal places. And we can see that this is a very strong negative correlation. A very strong negative linear correlation, which suggests that the prediction is valid. But I think the validity, though, is not necessarily tested by the correlation coefficient, but I guess it's the conviction of how true that is. But again, yeah, whatever, guys. Questions have been asked, we just answer, okay? 2 marks, I guess, getting the correlation coefficient and, explaining a bit. That should be good. 1.4 says, use the answer to question 1.1 to write down the estimated average yearly decrease in the selling price of these cars. Obviously, the average decrease is the gradient. So we know that the average decrease is equal to 0 minus, what is this? Minus 22,988, 2. Right. So that would be, by the way, it says the average yearly decrease in the selling price. Okay, do we write it as negative? That's where the question is. Okay, all right, okay. Yeah. It is what it is, right? So that is the one, guys. I don't know if I'm answering the question, but it is what is coming up from that equation, isn't it? Because that's exactly what is responsible for the decrease in the selling price, and that gradient is what it is. So do we put rands there? No, I don't think so. We don't put rands. Okay. Right, so this is done, folks. Very easy question. But rather the numbers that we put here, we were not used to them like that. We are used to perhaps using this, and then we're told this is in thousands after all. Then we do the equation with those numbers, and when we calculate the prediction, we multiply by 1,000. But I guess we had to face it as it comes, hey? Yep, let's get to question 2. So this was more like homework, isn't it? Yeah. It was more like homework. Let's get to question 2. 2.1 says, the cumulative frequency table below shows the amount of time that people spent on a particular website on a certain day. So up to 20 minutes, it was 16 people, more than that. But again, this is a cumulative, so it means we add something to this 16. So this 40 is from 16 plus something, isn't it? And this keeps on going like that. So as you can see, everything says 0 to because we are doing the cumulative frequencies here rather than the corresponding frequencies of each class. But what is easy to tell is the fact that the first class here is 0 to 20. The second class is going to be from 20 to 40. Then the third class is going to be from 40 to 60 and so forth. Okay. It says how many people visited this website. We know that the last cumulative frequency here is the total of the frequencies. So we go straight to business. 2.1.1. We know that it's 70 people. Okay. Easy. So 2.1.2 says, how many people spent more than 40 and up to 80 minutes on the website? Okay, more than 40 up to 80. Okay, right, so this one is a bit tricky, isn't it? Yeah, it's a bit tricky, this one. So more than 40, it means we want these guys here and they. Those are the guys we want. So obviously, to get the numbers right, what we're gonna do, we're gonna take 59 and subtract 40, right? So 59 minus 40 gives us 19. So this means these guys are 19. Okay, that's more than 40 up to 60. They are 19. And then we do the same here. Say 67 minus 59. So there's 8 people here in this group. So obviously we just add those two. Yeah. So that would be 19 plus 8. So we get 27. So we can say 27 people. Here an answer only is good enough as long as you know what we did. So we know that that was a cumulative, meaning we added what was there as well. So we just take this and subtract the previous. It gives us the frequency here, because that previous cumulative frequency plus 8 should give us 67. Same thing, to get that 19, we had to say 59 minus 40. Then it gives us the 19, because to 40 we added 19 to get 59. All right, so that's cool. And then we can even do the others so that we can just get ready if we need to. So 70 minus 67, it's 3. So we know that there's 3 people. These are the frequencies in brackets. Then here we're going to have 59 minus we're going to have 40 here minus 16. So that's 24, right? And then the first is always the same, isn't it? Doesn't change. The cumulative frequency, the very first one, is the same as the frequency at the beginning. Okay, see, we need to draw a histogram, so that's good. So 2.1.3. Okay, so I've got the graph paper here. I can just say this is the histogram. I don't have that grid. Usually it makes it a little bit better to use the grid provided. So the histogram of data. So if we look here, classes are increasing by 20, so to speak. So we're going to do that. Say, okay. Okay, let's see. Let's see, if we say this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, I think it's going to work. So we just say this is 20, 40, 60, 80, 100. 100, not 100. It's 100. All right, okay. Right, so let's see. Here we've got up to 70, so we can just say 10, 20, 30, 40, 50, 60, 70. It's all good. Nice and easy. Now the histogram is only going to use frequencies, not cumulative frequency. So this is the minutes. Or we just say time in minutes, sorry. Okay, good. So this is 0. Nice and easy. So now what do we do? Well, we know the first class is 0 to 20. The frequency is 16. So 15 is over there, 16 perhaps. Okay, let's just do this nicely, you see. It is best if we do it nicely. I need a vertical line and a horizontal line. So if we say this is 15, 16 is almost there. And then this is where our histogram is going to be. Right. Okay, maybe let's leave this one for now. Okay, it's done. That's the first block, nice and easy. Now let's get to the next one. The next one is going to be 20 to 40, and 20 to 40 is 24 people. So this is 20, 25, 24, somewhere there. Okay, so with this one, we just draw that extension. Okay, then the next one is going to be 40 to 60. Forty to 60 was how many people? 15, 19, sorry. So there's 19 here. So just before 20. All right, okay, all right. So the nice thing here is we're just drawing the things. We're just drawing the things. So what is irritating about this work is that you have to do a lot. Okay, maybe this one is not needed. Right, so let's have a look. Yikes, I didn't clean up. The histogram must not look like that. Okay. I don't need to remove these guys though. Those ones can stay. Nice. Next one is 60 to 80. There's just 8 people. 10, 9, 8, somewhere there. Okay. A little bit, a little bit, a little bit, a little bit, a little, a little. Last one. 80 to 100. There were 3 people only. So if we say this is 5, 4, 3, somewhere there. Yes. Yes. Good. So our histogram, guys, is complete. That's how it should look, ne? Oskov. Right. Well, there's no need to color it, but I just did. So basically, guys, we plot the class with its corresponding frequency, not cumulative frequency, okay? So that was just the trick here. And you know what, guys, as I said, you will always get bonuses. Remember the video I dropped before the exams had a histogram. That question from the Northwest from 2024 trial paper had exactly this kind of thing. And here you had it coming to you. Yes, in a very interesting way rather than the usual. But what's important is that, guys, you were primed before the exam. So you had a bit of an advantage, I guess. Of course, it depends on whether you take that advantage or you don't. So 1 point. Ooh, that's 2. So this is 2.1.4. It says, comment on the skewness of the data. So what will you say, folks? What sayest thou? Well, we can clearly see, guys, there's more people in the first half, I guess, than in the last half. Because you can see, if we say this is the middle class, so to speak, it separates two classes, I guess. We can see there's more people to the left than there are people to the right, isn't it? So this is skewed to the left. So this is very easy. So this is skewed to the left, or some people may say this is negatively skewed. That's all. Just 1 mark. Nice and easy. So what do we have now? 2.2. Okay, maybe we can sort it out here. 2.2 says there are 9 players in a basketball team. The coach calculated that on average, each player scored 12 points during the game. Okay, the points scored by 8 of the 9 players from the team is shown below. So let's see, 1, 2, 3, 4, 5, 6, 7, 8. Okay, it says now how many players' point score was outside 1 standard deviation of the mean score. Okay, so that's easy. We need to find the mean, we find the standard deviation, and we do the necessary calculation. So let's first see what is the mean of this data and what would be the standard deviation of the x variable. So obviously, folks, what we do, we go to mode just to make it easy for ourselves. Stat. This time we're going to choose 1 variable. Okay, then we put the numbers 11, 14, 19, 20, 8, 10, 2, 14. So I've got 8 entries. We go shift number 1. This time we go for the variance, which is 4. Now here we choose the mean. So the mean here is 12.25. And we repeat this. Shift 1, variance, we choose the standard deviation. So this one is 5.49 to 2 decimal places. Of course, the standard deviation, you wouldn't really win if you want to do it manually, although there is a way. But this is best to just use the table for everything. So now what we know is that 1 standard deviation of the mean is such that we've got the mean minus the standard deviation. And then we've got the mean plus the standard deviation, right? So we've got 12,25 minus 5,49. Then we've got 12,25 plus 5,49. This means the one standard deviation of the mean is going to be this. So 12,25 minus 5,49 is 6,76. Let's get to the next one. So we've got 12,25 plus 5,49. So this one gives us a 17,74. Right. So one standard deviation of the mean is this. So anything that's outside here, because we're saying outside. So we can see the value less than 6 here is 2. That falls outside one standard deviation of the mean. And the value more than 17 here is 19 and 20. Right. Right. So there's 3 players. It says how many players points. Okay, there's just 3. So we can say therefore 3 players points were outside one standard deviation of the mean points. Nice. So this question was asked in a nice way for a student to do more work at once. Otherwise, it's not a difficult question, hey? Yeah. So we get a mark for these, né? And we get a mark for the answer. And we get a mark for those. So that's how we score those 5 marks. And for a total of 12 marks. Easy. 12 marks. All right. Now let's get to some serious stuff. The real maths. So question 3 reads, in the diagram P, a point in the second quadrant, Q, a point in the third quadrant, and R, a point in the first quadrant, are vertices of triangle PQR. The angle of inclination of QR is theta, so indicated. Now, folks, we know that if we've got all these points, we can do a whole lot of things. Let's just get to business straight up. Calculate the length of QR and leave the answer in the simplified set form. Easy. So we know that QR is going to be the square root of x at R minus x at Q all squared plus y at R minus y at Q all squared. So this is the square root. X at R, that's 12 minus 4 is going to be plus 4 all squared. The y at R is 2 minus 6 is going to be plus 6 all squared. Let's get it nice and easy. So this is 12 plus 4 all squared. Hey, please go back to the computing mode and leave the stats. See? Certain notations on the calculator become a problem if not corrected early. Okay guys, this one, the calculators you guys have already make this easy. So this is 8 root 5 units. It already has simplified it. Our calculators of old would not do it. The student would have to do it. Sometimes I wish it would be like that, because students need to know how to manipulate these without the calculator making it too simple. Otherwise, substitutions and answer, guys. Straightforward stuff here. 8 now. 3.2 says we need the gradient of QR. Easy. Okay, y at r is 2 minus that is going to be 6 divided by 12 plus 4. So this is 8 and this is 16, so this is a half. Nice and easy. Okay. Again here, substitutions and answer is what matters. So 3.3 says calculate the size of theta. Nice and easy. Tan theta is equal to the gradient of QR. This implies that our tan theta is equal to a half. Therefore theta is going to be the arctan of 0.5. Right. Shift tan 0.5 is 26.57 degrees to 2 decimal places. Again, folks, I guess substitution and answer is what matters here. So essentially this exam was meant to look like homework. Very strange stuff. Determine the equation equation of QR. Okay, easy. We know that QR as a vector on the Cartesian plane is such that y is equal to a half of x plus c. You can use any point. So through point R, which is 12 and 2. 2 is going to be half of 12 plus c. Therefore our c, this is 6, we transpose, we get minus 4. Therefore the equation is a half of x minus 4. All right, okay, all right. Whew, this one was easy, eh? Hypo. This substitution and the final full answer is what matters. The rest is your problems. So 3.5 says PQRS in that order forms a parallelogram. Write down the coordinates of S. So this is easy. So all that we know, folks, is we can use the sides of this, because it says PQRS, so meaning S is in the first quadrant some way. Right. So there is our parallelogram. So we've got all those points on the palm. So this is point S. And we want the coordinates. At this point, nobody cares how we get them. The fact of the matter is we need to just write down meaning, answer only, folks. So how are we going to do it? Well, we check. We moved this point Q to P. How did we do it? From minus 4 to minus 1, what did we do? We said minus 4 plus 3, right? So we added 3. We shifted that point 3 units horizontally. And so we should do the same here. 12 plus 3 is going to be 15. Right, so if we moved this point 3 units to there, then how will we move this one up there? Same thing. Horizontally, it must be 3 units to the right. Now, by how many units did we move this one up? Well, we look at this. 6 to 8. What did we do? Minus 6 to 8. What did we add? Okay, let's just say 8 plus 6 is 14, right? So we moved it. We moved this one 14 units because minus 6 plus 14, yes. So if we added 14 to get there, we're going to do the same. 14 plus that takes us to 16. Nice and easy. Of course, guys, I'm just using, whether you call it symmetry or the idea of translation across, or at least on the horizontal plane and the vertical plane for certain structures, because of certain points are mirror images of each other, so we play with that. Another student who doesn't really know what to do here, because this may look very difficult, find the midpoint of this diagonal. Find the midpoint of that diagonal. And then, once we do that, we know that the diagonals of a palm bisect each other. So you can use, the midpoint equation. Let's check it out. So we've got 12 minus 1 divided by 2. So this becomes 11 over 2. And then let's see. This is going to be 3, right? Because this plus that is 10. Actually, no. 5. 8 plus 2 is 10. So this gives us 5. Now, if we do the same here, we want to go to S from there. So we know that we're going to have y at S minus 4 over 2. So it's going to be equal to 11 over 2. So just say 11 over 2. We then multiply by 2. We get 11, and then we add 4. Gives us 15. Can you see? Good. Same thing here. When we want the y value, we're going to say y there minus that y value divided by 2 should give us 5. So 5 by 2 is 10, right? Then we add 6. So it gives us 16. So this is good. So there's many ways of looking at that, folks. But I have taught all the techniques when dealing with a parallelogram. So students should find this question too easy. Now point T is a point on QR such that PT is perpendicular to QR. Okay, we can do it. Remember these are constructions. By the way, folks, make sure that any constructions you make, you show them in either broken lines or dashed lines. Or carelessly we say dotted lines, even though we don't really do that. But of course with a pencil or a pen on paper, you can achieve that. Right, so we're told that this is point T. So we want the coordinates of T. Okay, so this is a bit of an interesting question, but not too difficult. So if this is the case, we already know that this is the point of intersections. Yeah? So what are we going to use? The gradient to find the equation of PT. Then we solve simultaneously. Nice and easy. So let's see. We understand that the gradient of PT is going to be the negative inverse of the gradient of QR. So this is going to be equal to minus 2. Right. The reason, because the gradient of PT multiplied by the gradient of QR should be minus 1. That's why we know. We can say then PT, maybe let's not say that. We can say also PT as a vector on the Cartesian plane. This is basically minus 2x plus c. We can use the point P. 8 is minus 2 into minus 1 plus c. Therefore, c is, so this is plus 2. We put it across, we get 6. Right, makes sense because this line cuts before 8. So y is minus 2x plus 6. We can say then T is a point such that minus 2x plus 6 is equal to, what was the equation of QR? A half of x minus 4. Now we move everything to one side. 2 minus a half, it's going to be 2.5, right? So that is minus 5 over 2. X equals minus 10. So therefore our x is going to be, right, 2 times 10 is 20 divided by 5 is 4. And the corresponding y value would be, we substitute into the easiest, it's going to be minus 2 into 4 plus 6, which is, this is minus 8 plus 6, it's going to give us minus 2. So we can say therefore point T is the point where the x coordinate is 4, the y coordinate is minus 2. And this makes sense because this is a point in the first quadrant. This is a point in the first quadrant. Great stuff. Sorry, not first, but fourth quadrant. Yeah. Otherwise, that was another way of just getting simultaneous equations involved. So this is a mark. This is a mark. This is a mark. This is a mark. So 4 marks. Okay, so perhaps we can say the method here is the extra mark. Although we're getting marks elsewhere, we need to show that ordered pair. If not, we may lose a mark here because the intention was to show the coordinates in ordered pair. Right, easy, ne? Hi guys, if anyone says they failed paper 2, come here, I must kill you. Calculate the area of the parallelogram PQRS. Easy. So we've got here 4 and minus 2. Obviously, guys, we know that these are congruent triangles that are made up by the diagonals. So all we need is to just find the size of this length here, which becomes the height. Once we find this, we've already done QR. So use QR as the base. We use that as a height, PT. Then we double the area because these are congruent triangles. So it's very easy. We will start by saying in, maybe not even there, we can just say PT. It's going to be the square root of x at t minus x at p all squared plus y at t minus y at p all squared. This x at t, that's 4 minus 1 is going to be plus 1. This is minus 2 minus 8 all squared. Let's get it done. Square root of 4 plus 1 all squared minus 2 minus 8 all squared. The answer is 5 root 5 units. Now, we want to solve the problem. We can say then area of PQRS is going to be equal to 2 times the area of triangle PQR. Right, so this is equal to 2 times the base is going to be half the base, which is QR, times the perpendicular height PT. QR, we got, what was it, 8 root 5, was it? Yes, we got 8 root 5 multiplied by 5 root 5. Nice and easy. So we've got 8 by 5, it's 40. And 40 times 5 is 200. So this is going to be just 200 square units. Nice and easy. Nice and easy. All right, so I guess this is a mark, substitutions, and final answer. Okay, easy, 18 marks to score. Okay. Yeah, the examiners didn't want to examine at all, eh? They did not. Anyway, folks, it's your lucky time, I guess. It's your lucky time. You will never get this ease in a maths paper 2, especially for this question, really. The last few questions are so easy. Anyway, question 4 says, in the diagram M, which is a point in the second quadrant according to the sketch, is the center of the circle that intersects the x-axis at A and B. So these are the x-intercepts. C is a midpoint, is a point such that the line drawn from M to C is parallel to the y-axis. So any line parallel to the y-axis, what is it? It's going to be perpendicular to the x-axis. Now, we know that from theorem 1, a line from center perpendicular to chord, because AB is the chord, will bisect the chord. So do not forget. Okay, right. At D, okay, good. MC intersects the circle at E. So we're given the coordinates of E. So this is minus 6 is 2, minus 1. Okay, point in the third quadrant. Now tangents drawn from C touch the circle at A and B. So we know that the tangent is itself perpendicular to radius. Good. So what do we have here? We know that technically tangents from the same point outside the circle are going to be equal in length. So with the radii also equal on this side, it already tells us that our MACB is a kite. And we know that the diagonals of a kite meet at right angles, and the longer diagonal bisects the shorter one. In the shorter diagonal, the longer diagonal bisects the shorter diagonal. At the same time, it bisects those angles from which it comes. So just remember these, guys. So these are all the things that whenever you're given a sketch, you just revise all of these. Now it says write down the value of P. Well, what is the value of P? It's going to be -6, isn't it? Because if there's any point on that vertical line, the X value is the same. So 4.1, we know that P is -6. Nice and easy. 4.2 says show that Q is equal to 4. Okay, that's a bit of work, but not too difficult. I didn't read. Okay, AD is Q minus. Okay, so we've got Q minus 1 units. So obviously, folks, this pushes us into this triangle. This pushes us into this triangle. It's a right-angled triangle. Right. So what is the story about that triangle? It's a right-angled triangle. And we know this length. It's given as Q minus 1. And what else do we know, folks? We know very well that the radius of this circle, this one is also a radius from M to E, and it's a vertical line. So a vertical line is going to be Q minus -1. So we know that the radius becomes Q plus 1 by using this line. If I may show it. Papela, when are you not a straight line? Yeah, but yanqhela. So that is the story, guys. So if we look at that line, it's always going to be y top minus y bottom. So Q minus -1 is going to be Q plus 1. And since these are all ready, so this is going to be Q plus 1 as well. Right, because these are all ready. So this was a bit tricky, I guess. Students would not see this one coming. But understanding what needs to be done, perhaps that's the question that is a bit interesting. All right. Okay, all right. So what are we going to say, folks? We are going to say, first of all, in triangle MAD, MAD, what do we know? We know that MD is perpendicular to AD. Right, what's the reason for this? We know that a vertical line is always perpendicular to a horizontal line. That's the best I can do. Maybe let's even say something else rather than have perpendicular. You can just say MDA is 90 degrees. That's the most important thing to say. We can also say that essentially AM is going to be equal to ME equal to Q plus 1 units. Okay, so that's easy. These are ready. Okay, please guys, be very systematic and have a structure in what you're doing. We can say then, we know that the square on AM is equal to the square on the other two adjacent sides, AD squared plus so this is AD squared plus plus MD squared. This is from Pythagoras. Okay, so AM, we saw that this is Q plus 1 all squared equals AD squared is Q minus 1 squared plus MD. Remember, it's just Q units. It's just Q squared. Okay, so it looks like we have no choice but to FOIL out. So we get Q squared plus 2Q plus 1 equals Q squared minus 2Q plus 1 plus Q squared. So there's a few cancellations here. And then we move everything around. So we're going to get Q squared here. Minus 2Q is going to be minus 4Q equal to 0, because minus 1 plus 1 is 0. Okay, we take out the highest common factor. We've got Q into Q minus 4 equal to 0. Therefore, Q is indeed equal to 4 because Q can't be 0. Hey, Bo, what am I doing? Q cannot be 0, so it's either you ignore it or you just write Q is not equal to 0 and or Q is equal to 4. Okay, so that was a bit tricky, but again, not really an unfamiliar story to deal with. This is key, okay? Very important, and the radius here is very important to substitute into Pythagoras and to factorize perhaps. Otherwise, everything was straight to the point. Yeah. Okay, now 4.3 says, determine the equation of the circle in the form Okay, so it's not a problem. So the equation of the circle here is going to be x minus 6 is going to be plus 6 squared plus x minus 4. Remember, Q is 4 all squared equals, now what's the radius? Remember the radius, we said it's Q plus 1, so it's going to be 4 plus 1. That's 5. So 5 squared is 25. At this point, guys, if a question says determine, it's just straightforward. We get a mark for the left-hand side and for the right-hand side. 4.4 says if the circle is translated 2 units to the left. So this circle is translated 2 units to the left. Determine the minimum distance between the circle and the y-axis. Okay. So if we move this circle 2 units to the left, right, first of all, let's appreciate something. What we can appreciate is that we need to know that, wow, I just guessed this whole thing right. How many units is this? It's 6 units. This distance is 6 units. Okay, so if this distance is 6 units, right, what is the smallest distance from this to the y-axis, which is this distance right here? Okay, I kind of lied, didn't I? Yes, I lied. This is not 6 units, but 5 units, sorry. This is 5 units. Because it's the radius of the circle. Now, we know that m is 6 units from the y-axis. So what does that mean? It means this distance is just 1 unit. Right. Now when we translate this 2 units to the left, we are going to increase that distance by 2 units. So it's going to be 3. So we can just say 4,4. This is just 4 units. No, 3. What am I saying? Because obviously if we move the circle 2 units to the left, so we're going to have perhaps 1, 2. So this circumference is going to be sitting there. Now do you see 2 units plus 1 is 3. So we get 3 units. So there's no need to sweat here. Nice and easy. So 4.5 says, calculate the coordinates of A and B. X-intercepts, not a problem. Wow, look at this, guys. This is wrong. You don't do these things. So we know that x plus 6 all squared plus 0 minus 4 all squared is equal to 25. So this implies that x plus 6 plus, this is 16, is equal to 25, implies that x plus 6 all squared, 25 minus 16 is 9. Yeah? And we can take the square root on each side. So we know that our x plus 6 is going to be plus or minus 3. Therefore, x is equal to, when this is minus 3, this becomes minus 9. Or x equals, when this is plus 3, this becomes minus 3. So we can say, therefore, A is minus 9 and 0. And B is minus 3 and 0. Very easy. Easy peasy lemon squeezy. Right. We can clearly see, guys, if this is 6 at D, so we're moving 3 units to the right and 3 units to the left, because those should be equal on either side. So those coordinates make sense, because we saw that Q was, in fact, I could easily have used my symmetry here, that Q minus 1 is 3. So if this is 3 units, I know that this is minus 6. Minus 6 minus 3 gives me minus 9. And then minus 6 plus 3 gives me minus 3. So we could have used symmetry than the calculation. But it's done. Nonetheless, so substituting the 0 there, x-intercepts, we know y should be 0. And then getting those coordinates. Good. It's easy. Get 4.6. 4.6 says determine the equation of the tangent BC. Okay, so that's easy. We know that the gradient of our tangent multiplied by the gradient of MB should be -1. It's because the tangent is always perpendicular to radius. So this implies that our gradient of our tangent times, now this one is going to be y there, which is 4 minus 0 divided by, this is -6 plus 3. So this means our gradient of our tangent into, this is -4 over 3. Is equal to -1. Therefore, the gradient of our tangent is going to be 3 over 4. Yes, yes, and yes. Strange though, it's not quite a gentle one, but this is suggesting so. Okay. Okay, no. Yeah, it's fairly steep though, but it's okay. It's a positive gradient. We can say then the tangent is given by equation y equals 3 over 4 x plus c. So we use point B. Can say therefore our c there, this is -9 over 4. When we transpose it becomes 9 over 4. Okay, so we can say therefore our equation here is going to be 3 over 4 x plus 9 over 4. Wrong or right, it is done, guys. Okay, we did it. Right, so 4 marks here. So I guess getting the gradient of the radius and eventually the gradient here, substitution, and the answer. Easy. Now let's do 4.7. 4.7 says write down the coordinates of C. Okay. Obviously, guys, we know that C has the same x value as the others. But now we just need to find the corresponding y value, which is easy. We just put 1 in there. So we've got 3 over 4 into -6 plus 9 over 4. So this gives us coordinates of C to be -6 is to -9 over 4. Nice and easy. Okay. All right, okay. So question said write down, no explanations, so we get 2 marks for each. Now 4.8 says calculate the size of ACB. Okay, so we want this angle. Well, how will we find that angle? Okay, we just need to find one of these x's, and then we double it. Easy. If we can find one of these. And the good thing is we know this, we will know that. So if we say sine of this angle, it's going to be the opposite of a hypotenuse. So technically, essentially, if we do this, If we zoom into this triangle, if we zoom into that triangle, we can use our trig ratios here to get it done. Because we just say that, and then we double it for this whole thing. Easy. So we'll just say in triangle ACM. We know it's a right-angled triangle. So we know that sine of MCA, the middle cerebral artery. Yes, it's going to be the opposite side, which is MA, over the hypotenuse side, which is MC. Sine of MCA, MA is the radius, so the radius is 5 over MC. By the way, we saw that this is minus 9 over 4, so basically it's just going to be 4, but I would like to show this one perhaps so that you know where it came from. So we're going to have 5, which is the radius, but this one is going to be y top minus y bottom. So this implies that sine MCA is 5 divided by 4 minus into minus 9 over 4. We get 4 over 5. Okay? So we can say therefore MCA is arc sine 4 over 5. Arc sine answer gives us 53.13 degrees. Okay. All right, okay. So we can say therefore this ACB going to be 2 times 53.13 degrees. So we times this one by 2, we get 106.26 degrees. Right. It's an obtuse angle. It makes sense. So we had to think about it constructively. Again, guys, these questions are very nice because they test your resilience. But again, it was easy to see what to do here. Whatever technique comes to mind, use it if you can. So for me, this is good. How many marks was this? 4. And then can say substitutions 2 and 3, 4. Maybe not here, but this one. Yeah. All right, guys. Otherwise, this was a very easy 21 marks to score. As you can see, we're just cruising. We are just cruising. Of course, those of you who want this memo, it's going to be in the description. I tried to write it in a clear way. But where it's not clear, you're just going to have to listen from, the presentation right here on the video. Now let's get to trig, a bit of algebra in geometry. So this is question 5. So question 5, we've got 5.1, which says 1050 equals k. Remember, we need to show this as a ratio. And do not forget there's always that question of not using a calculator. Now what we know is that 50 is an acute angle. So this is 50 degrees, that should be 40, its complement. We need to quickly get these things sorted, folks. There are no excuses that a student can make here. You don't need to be told to do the diagram, but you just do it. 10 is opposite over adjacent. So that means the hypotenuse side from Pythagoras is going to be 1 plus k squared, isn't it? From Pythagoras, we know that r squared is going to be x squared plus y squared. Now r squared equals, we've got 1. Therefore, r is going to be 1 plus k squared. This does not need you guys to wait. You do it. Whether you're going to need it or not, do not wait until you need it. Just do it. Right, it says express each of the following in terms of k. K cos 40, can you see? Can you see already we are looking at 40 now? Cos is going to be adjacent over hypotenuse, so it becomes k over the square root of 1 plus k squared. Can you see? We needed the diagram and it's saving us the trouble. I taught how to use this diagram, terminal arm diagram business, so if you guys don't pay attention, then it's going to be your problem. Right, just a moment. All right, so how would we mark this business, folks? First of all, we get a mark here. We get a mark for the substitutions, and it's over. It's done. So 5.1.2 says we've got 2 sine 25 degrees times cos 25 degrees all over minus 2 plus 4 sine squared 25 degrees. So we can see there that's a double angle identity for sine expanded, so we contract it. It's going to be sine of 2 times 25 degrees divided by, we take out the highest common factor here, we take minus 2, so we get minus 2 out, we get 1 minus 2 sine squared 25 degrees. Okay, so this is equal to, this is sine 50 degrees divided by minus 2. This is this cos double angle identity, so this is cos of 50 degrees. Right. So if we factor out the minus 1/2, we end up with just sine 50 degrees over cos 50 degrees. So this is minus 1/2 of the tangent of 50 degrees. So we can say this is minus k over 2. This one is easy. So obviously, folks, this reduction is important, factorization important, recognizing the double angle identity, and the final answer. Easy stuff. Okay. Not a difficult question after all. So 5.1.3 says sine of 10. This is the same as sine of 60 degrees minus 50 degrees. Okay, we want the angle involved and some special angle. So this is going to be sine 60 degrees cos 50 degrees. Sine remains. It's going to be cos 60 degrees sine 50 degrees. Okay. Right, sine 60 is root 3 over 2 into cos of 50 here. It's 1 over that thing. Cos of 60 is 1/2. Sine 50 is k over that radical. Right, so we just sort it out. So we get root 3 divided by 2 root so this is k. Okay guys, so this one is a bit silly, but it is what it is. So we get here root 3 minus k all over 2 root 1 plus k squared. The trick here was to use compound angle identities. That was the key. This is mark-worthy, the expansion, and essentially this, okay, we can say that whole thing and the answer. Okay, right. Now let's move. So we've got 5.2. 5.2, we have this expression. It says simplify fully to a single trigonometric ratio. Okay, so we've got 5.2.1. So we have sine of 540 degrees plus x times cos of 90 degrees plus x divided by sine of minus x. Okay, let's sort this one out. This is sine of 360 degrees plus, let's see what is there. 540 minus 360 is 180. So this is plus 180 degrees plus x times cos of 90 degrees plus x divided by sine of minus x. Now we sort this out. 360 plus, in principle, that's first quadrant. So we've got sine of 180 degrees plus x times cos of 90 degrees plus x divided by sine of minus x. Now this is minus sine x times minus sine x, all divided by minus sine x. So this and that go away, and our answer is just minus sine x. Right, let's just choose a value for x to check if we are doing well. So what I often do I just choose that x is equal to 2 degrees, just a small angle. Then I put that on the calculator as well as this and see what I get. So let's start there. Minus sine of 2. So this is minus 0,0348994967. Now let's go to that one. So we've got sine of 540, plus 2 into cos of 90 plus 2, all divided by sine of minus 2. See, I get exactly the same solution. So this already tells me that I am winning. Please guys, check the solution so that you don't end up with a reduction that is not representative. There's no excuses for not checking. Okay, this is easy. Otherwise, how many marks are we getting here? 4. Okay. So obviously, folks, this is the reduction, and the final answer. It's the main reductions that give us the marks here. Okay, 5.2.2 says, hence determine the values of x in this interval, okay, all 4 quadrants, for which this whole shenanigan will be real. Remember, for real, it means our, whatever this, it means our minus sine x must either be 0 or greater than 0. Right? This dude must either be 0, because we can take a square root of 0, and something greater than 0. When this is not greater than 0, what happens? It's out. It becomes out. So it's just 2 marks here. Now I'm trying to think, what on the Lord's earth is this going to be? If we think of our Cartesian plane, we know that this is 0 degrees. When we complete a revolution, it's 360. We know that this is 90 degrees. We know this is 180. Then we've got here 270 degrees. We know that sine of 0 is 0. So 0 is good. And then here sine is positive. But because this whole thing is negative, so this is not going to work, that first quadrant. And of course, even 90 is not going to work. But in the second quadrant, sine is positive. It's still not going to work. But when sine is negative, because of the leading negative, we know that this is going to work. 270 is when sine is 0. So this is going to work. And it's going to work over there. So, so the values of x that will work here, we can just say here x is an element of, by the way, 180 is also included because sine of 180 is 0, isn't it? Yeah. So 180. So this is going to be from 180 degrees inclusive all the way to 360. Otherwise, those in the first quadrant and second quadrant are not going to work because our sine x would be positive, and as a whole that thing becomes negative, and we can't have a negative under the square root. So the restriction is that for real roots we cannot have a negative under the square root. That's the key. Okay, So this is what I would write, because there's too many values, so you don't want to waste your time looking for specific values. It just doesn't work, okay? Yes, there may be not so many after all, but I'm feeling like all of those values in the fourth quadrant, third quadrant, including the x's themselves, are going to work. Now are you gonna look for each one of them? Just look at the mark allocation, and then you realize here that all we need is just to define, you know, those domains in which this is going to be possible. Otherwise, we are done here. Okay, so this is very interesting. Very interesting. Again, we have done a lot of practicing around this. This should have been a walk in the park. Okay, so the boundaries, they are very important. Now that was an easy 17 marks, guys. I don't know, the examiners were not feeling like examining, eh? Not at all. They were just tired. Or is it? Is it the GNU trying to make itself look like it's successful, eh? Because this GNU thing, it's not working. I actually had high hopes for this GNU business, that it's going to really make South Africa better. I feel like the country hasn't made any strides at all. Instead, it looks like it's taken a stall. Yeah. Anyway, that's just my feeling. I don't know what others think or what you think, but I feel like this paper is not good. It's too easy. It's too easy. It's going to give us a wrong reflection that, look, since the GNU's inception, students have been passing in numbers like they did last year, but reality is, folks, this is manipulation. We can't accept this kind of thing. I mean, you can't ask such easy questions in the exam, eh? Final exam, no ways. Remember, the final exam, guys, should be the one where we tie the knots. Trials, term papers, this is where we give a student a chance. So the questions, in my opinion, should be easy, with a flavor of hard questions. But for me, the finals, in my opinion, should have all the hard questions. Very few easy questions. In fact, easy questions should have less marks. Then very hard, 80% must be the hardest question, so that we know if a student is for maths or not, or for the sciences or not. I'm a bit disappointed with these papers. They look too easy for my liking. But again, good for my students because they were over-prepared. Right. Anyway, guys, leave the nonsense alone. I talk too much, you see. Question 6. What is the story there? Prove that this, can you see, guys, this came from last year's May-June exam. Definitely this one. It's just that somebody played with the signs here. That's all. Somebody just toyed with the signs. Okay, so we're going to take the left-hand side. So 6.1 LHS is the tangent of 180 degrees minus x multiplied by 1 minus cos squared x plus cos squared x. So this is equal to, we know that this is going to be minus 10x into 1 minus cos squared x. Remember, with these ones, we keep them as long as possible. Plus cos squared x. Remember, once we see this, it means we had about 4 terms in the numerator, and then we factorized by grouping. So we need to at least expand to 4 terms. So this is equal to, we know that this is minus sine x over cos x into 1 minus cos squared x, plus we change this, it's going to be 1 minus sine squared x, isn't it, from square identities. Now this gives us 4 terms nicely. So this is going to be minus sine x over cos x. Remember, we're foiling this out. This one is going to be plus sine x over cos x times cos squared x, plus 1 over 1 minus sine squared x over 1. Now things start doing the things. So let's see, we've got minus sine x over cos x plus sine x cos x over 1, plus 1 over 1 minus sine squared x over 1. Now we know the common denominator here is going to be cos x. Right. But since we want this to be negative, okay, let's just leave it like this for now. But I'm feeling like if we want that to be negative, we might as well pull out a negative here, so everything changes in the numerator. But let's see. So we're going to have this times that is going to be basically minus sine x, and then we check here, cos x is going to be basically plus sine x plus cos squared x, right, plus cos x minus sine x what is this now? This is sine squared x cos x, ne? Good. Right, so we want to factor out a negative here. So we're going to have minus into sine x minus minus, we might as well bring something that's like it, but I think it's already this one. So I'm thinking, what are we trying to aim for? Okay, we want to bring in that one. So this one becomes positive sine squared x cos x. I'm already grouping. And then so I'm already grouping these. Now, the next one here is going to be a bit tricky. It's going to be cos x. But now this cos x is going to be negative cos x. Then that guy becomes minus sine x cos squared x. Now if we pull out a negative there, this one becomes positive. Whew. Very tricky business right there. This is all divided by cos x. Now that can be considered to be coming straight down. So all we have is we factorize there. So we're going to end up with taking sine x out, In there, what we remain with is going to be 1 plus sine x cos x, minus we take out cos x. What remains is 1 plus sine x cos x, all divided by minus cos x. Now we see that this bracket is common. We take it as the highest common factor, and whatever remains is going to be sine x minus cos x into our highest common factor is 1 plus, come on man, 1 plus sine x cos x all over minus cos x. So this is equal to the right hand side. Okay, this one was a bit technical, but for those who practiced that May June paper from last year, this was a walk in the park, and we did during the class, So guys, can you see? This was nothing but free marks for you folks. 6 marks. Oh, I'm even lazy to show where the marks are. But obviously factorization here is key, and perhaps that should be our last 2 marks. Maybe last 3, even though this is given, but I think how we get to it is very important. Changing this, that's a mark. Yeah. 1, 2, 3, 4. I think factoring a negative 5, and then using the square identity here, 6. The rest is algebra. Okay, nice and easy. So we've got 6.2. 6.2 says if it is given that sine squared x, cos squared x, and half sine 2x are the first 3 terms of an arithmetic sequence. So we've got an arithmetic progression with sine squared x, cos squared x, half sine 2x. Okay. Now it says the constant difference is not 0. Okay. Determine the general solution for x. Okay, so we know, folks, that essentially cos squared x minus sine squared x must be equal to half sine 2x minus cos squared x, right? Each is equal to the common difference. So we know that this is nothing but cos 2x when we use our identities. Okay, I'm feeling like I'm doing something wrong. Let's not do that. Let's not do that, because we cannot get rid of this cos squared x here. So for that reason, we leave it like that. So this is cos squared x minus sine squared x. Don't know why I'm writing like that. This is equal to 1 over 2 into, this is 2 sine x cos x minus cos squared x. Right, so we know that this and that go away, but we can see a quadratic coming up. This plus that is going to be 2 cos squared x. Then the middle term comes in. We're going to have sine x cos x minus sine squared x equal to 0. We can factorize this. If not, we use the quadratic formula. So this is 2 cos x Obviously, this is going to be sine x. Now, to get a minus, this one must be negative, this one must be positive. Great stuff. So we know that this implies that 2 cos x is going to be equal to minus sine x, or cos x is equal to sine x. Yes, and yes. Okay, now this one is good because it makes our lives a lot easier. For this one, we can divide by minus 2, right? Minus 2 cos. Let's just divide by minus cos x. Remember, we can divide by anything we want. Nobody can tell you otherwise. So this goes, that goes. So what we remain with here is just 10x is equal to minus 2. Or here we divide by cos x. So this means we're going to have again 10x is equal to 1. Right, so we know that this implies that x is going to be the arctan of minus 2 plus k, 180 degrees, or x is going to be arctan of 1 plus k, 180 degrees, where k is an element of integers. So therefore, our x is arctan of minus 2. It's minus 63,43 degrees. Remember, the period for the tan graph is 180. So this one is 45 degrees plus k, 180 degrees, where k is an element of integers. Now that's the general solution. Okay. As we said, folks, once you say trig, anything in paper 1 can be used to construct an expression for trigonometry or trigonometric equations or expressions. As you can see here, we needed to use our knowledge of the common difference in an arithmetic sequence. Then from there, we got a nice equation, quadratics. We factorized, then we play with the identities up until we get something very nice and tasty. Yeah, so we get a mark for each one of these general solutions. For the technique, I think this and that is good. So first 4 marks are nice and done. Definitely, and of course, constructing the equations here, using our identities there. So we've got 1, 2, 3, 4, 5, 6. The 7th mark is when we factorize the quadratic. The rest is history. So 1, 2, 3, 4, 5, 6, 7. See, a very easy 13 marks to score. Great. So let's get to question 7. So question 7 says, in the diagram, the graph of f, which is equal to cos 2x, is drawn for this minus 135 to 135 interval. So write down the period of f easy. The period is 180 degrees. Very easy. And for those who don't know, we say period is going to be equal to the original period for a cosine function divided by the coefficient of the angle which is 2. This is for those who still don't understand what happened here. But obviously, I expect all students to not need to check this by now. Now, on the same set of x's provided in the answer book, I don't have it. Draw the graph off, so I'm going to draw it on this sketch. Okay, so this is easy, guys. It's not a big deal. It's not a big deal at all. So all we know is that that graph of 10 is going to be 2 times faster because of this business. Right. So the period is no longer going to be 180 but 90 degrees. We have it. And we shift every y value by 1 unit down. Okay. So obviously at 22,5, which is halfway here. Well, first let's start with the asymptotes. So the asymptotes are not affected by this, isn't it? This does not affect the asymptotes. Only the coefficient of x does. So the first would have been at 90. We say 90 divided by 2, it goes to 45. So we're going to have an asymptote here. Okay, this one is not quite a straight line. I don't know why this paper is skewed. Maybe because of how it was copied. Yikes. Anyway, let me try to manipulate it so that it does give me what I want. Yeah. Okay, guys. Shit. Shit. I'm sorry for the language, but you know what? I'm angry at this thing now. Why is it not straight, man? Now it tests my surgical precision, huh? Okay, it's not so bad after all, but it's not so nice either, because now I'm having an intention tremor here. Whatever this is. Yeah. So this is where we're going to have an asymptote. Right. The other one was going to be at 270. So if we divide 270 by 2, it takes us straight to 135. Also not the same. Okay, let's try our surgical precision. Okay, see, my problem is where my hand is resting and the screen is not as smooth. It's actually dirty. So my hand doesn't slide as nice as I wish. So there's another asymptote. Right. So always think about it. Now look at this. 135. Look at this. 135 from 135 to 90. To 45 is what? It's a period of 90 degrees. So you can see the period has changed. So this is good. And of course, we know that we're going to have another one here because it should have been at... inkinga yethu ke bafethu ukuthi logo akukho straight, man. The copying distorted this page, so zizobambi less lines. Zizoba snacks. And of course, guys, at minus 270 we're gonna have another one. So now it's gonna come down here, or it's gonna come up here. See, uyabona ke singiqhela wena man. This is testing my surgical precision. Okay, I make the best scars, I know. But yeah, this is not as easy for me to do as it is when I cut on the skin. Yes. So of course, guys, asymptotes are sorted. is nice, isn't it? So folks, I know that 10 of 0 is 0, ne? No matter how many times I multiply. So this one goes to -1 because we're shifting it down. Now 22,5, which is the middle here, this becomes an x-intercept because this would have been 1. When we shift it down by 1 unit, it becomes an x-intercept. Right, that's half of 45. So guys, it's nice to know these things, you know, you don't have to sweat, you don't have to struggle. So we can already see that, okay, all right, okay, we're getting the shape that we expect. And yeah, you know. So what happens at -22,5? Because it's going to be very important as well. Okay, maybe let's wait and see. Remember, this is going to be exactly -1. But now this goes to -2. So let's say if this is 1, this is -2. Okay, so this comes down here. Okay. Right. So this is -22,5 degrees. Okay, so that's what we have. So we can clearly see that we are approaching an asymptote. So this graph is easy. So let's just use a different color for these points. Okay. And then let's get to the other side. What happens here? We expect an x-intercept somewhere. So obviously 90 times 2. So 90 times 2 is 180. So 10 of 180 is 0, isn't it? Yeah. So we then take it down. So this one is going to go to -1 here. Yeah. And then before here, so let's see what happens there. So this is 45 plus 22,5. That should be 67,5. Okay, very important to think about that. That should be actually where we get -1, isn't it? Okay, let's see what happens there. So let's see, 10 of 2 times 67,5 is -1. So this goes exactly there to -2. Okay, so this looks like it's gonna keep doing the things. I'm expecting here to hit an x-intercept. Hey, but I feel like this is wrong, eh? Let's see, 90 plus 22,5. Let's see. So this is 112,5 degrees. If this is the case, I expect to hit an x-intercept here. Okay, so we see that But this is quite strange, is it not? It looks a bit strange. Strange. So obviously, guys, whatever this is going on, the pattern should repeat the same way. So let's see, what is minus 90 plus 22,5 is. So this is minus 67,5. So the pattern here is seemingly doing exactly as I hope. This is going to be minus 1. Superb. This should be 0, right? Yeah. So it's going to go to minus 1. And then there in between, let's see, minus 135 plus 22,5. It's going to be minus 112,5. That takes us all the way down. I hope I'm not doing mistakes here. It's so easy, you know. Let's see, 10, 2 times minus 112,5. It gives us minus 1. Minus 1 takes us to minus 2. This, that. And of course, we know that we're going to have this as an x-intercept, just like it was everywhere. So obviously, guys, we draw the graph now. Okay, guys, so there's the graph. Apologies for a bit of a delay, but you probably did not even notice. Just got a bit of a phone call. Anyway, so this is what this looks like. Okay. So this is what we should be presenting as the graph of the thing. Again, guys, pay attention to the shape. Just know where everything should be. Okay. The point of inflection has shifted down, so you cannot find yourself having that as the point of inflection. The point of inflection has shifted down, so the shape is going to be right about that line. Literally, we've shifted the x-axis down, so this looks all right. Anyway, folks, that's easy 3 marks for showing the shape, asymptotes, and the intercepts. So let's see, 7.3 says the graph of f is translated 45 degrees to the left to form the graph of h. Determine the equation. So those are the nice questions, isn't it? So we know that h of x is going to be f of x minus, is it minus? If we shift to the left, so this is plus 45 degrees, okay? So this implies that h of x is, this is now cos of 2, where we see x, we put x plus 45 degrees. So this implies that our h of x equals cos of 2 times 45 is 90 degrees plus 2x. So therefore, h of x is going to be equal to minus sine 2x using our core functions. This question, guys, has been recurring throughout. No excuses for getting it wrong. Okay. Right, and transformations of graphs is also very important. Can you see the examiner is not interested in giving a lot of marks? Yep, it's your own problem. So this means even an answer only is good enough here. So 7.4 says write down the range of h. Okay. Now the range of h, remember the coefficient of our thing is there, is 1 and minus 1. So the range is not going to change. So we can just say the range is equal to y values such that y is between 1 and -1 included. Nice and easy. So we got 1 mark for this. 7.5 says, determine the values of x for which this shenanigan here is the case in this interval. Now this is from 0. This is from here all the way. Okay, so let's see what's cooking there. We need to first handle that business here. So this is 1 minus 10 2x into cos 2x greater than or equal to 0. If we factor out a negative in the first bracket, we get 10 2x plus 1 into cos 2x greater than or equal to 0. So this means this is minus g of x times f of x must be greater than or equal to 0. Okay, see, very nice and easy. So therefore x is, now let's look at this. So basically we're taking the y values of g, we're multiplying by negative, and we want this to be positive. So obviously we already see that the g values are negative here, 0 and then positive. Negative, 0 and positive. Negative, 0 and positive, right? Okay, so that's what this is. Now what are we gonna do? We look at the y values of g. Let's choose another color perhaps. These ones are negative, 0 and then positive. These ones are negative, negative, 0. Ne? This is negative, negative, 0. So folks, we want a situation where we take the y values of f, we multiply them by negative, and then we multiply those to the y values of g, and these are to be equal or greater than 0. So the most important thing is that we know that these points are included. Okay? But now if we look here, the negative values, these are negative y values for g. If we multiply them by negative, they become positive. Now positive times negative is less than 0. So this is not going to work. Okay, this doesn't work. This doesn't work either. So all the way until this asymptote, we're not winning. But if we look here, we'll see that from this asymptote, say towards that point where these two are equal, I wonder what could be that. What would be this point? This is where I don't like it, but do we really need that point per se? Maybe not. Maybe that's why we don't really have to worry. So we can say from here up until the next asymptote, this is positive and these are negative. So if we take a negative and multiply by negative, it's going to be a positive. Positive times positive, that's positive. So this whole shenanigan up until here is working. Okay? So it's working. Then after this, it doesn't work. Okay? Because this is positive. When you multiply by negative, it's going to be negative. Negative times positive is not what we want. So our limit here is from this asymptote approaching this x-intercept. So this is good. Already this one did not work. Okay, all right, okay, but be very careful, folks. There's a small little interval here that should work. Okay, that interval should work. It's not the whole thing, because I'm looking at, from there, the y values are positive. When we multiply by negative, they become negative, and the negative times negative y values of f is going to be positive up until the asymptote. So this is good. Okay, so that's good. Right, and then let's check on the other side. What do we have? There's negative y values, negative y values. This becomes positive and negative, so this is not going to work. But most likely this one, this last interval, is going to work. Why? Because this positive times a negative is negative, negative times another negative is a positive, so it works in our favor. Okay, but those points where they are equal do not work in our favor, hey? None of them do. Okay, all right, okay. Great. And of course, we cannot include the asymptotes, because at the asymptotes, the other graph is undefined. Okay, so let's start writing. X must be less than minus 45. But greater than minus 67.5 degrees. Right. That should be the one. And then we see that the next interval works all the way until 22.5. Yeah. I see that, so we know that or x must be less than, not equal to, but less than 22.5 degrees, but greater than minus 45. Ne? Yes. This one works. Or x must be less than 135 degrees, but greater than. Now the question is, yeah, I'm thinking about it now. Actually, those values are included on the left, so that we cannot include the asymptote, but this can be included as well as that should be included. So this is 112.5 degrees. Okay. Yes. So be very careful here. 0 is included, so that's why I'm including those values. Because one graph is 0, so a product is always going to be 0. Nice, but don't include asymptotes. You will be killed and buried easily. Okay? Okay, guys, so this is it. So easy 4 marks here. So I don't know how. 1, 2, 3. I guess maybe simplifying so that we know where we're going. Otherwise, this one was a very nice and tricky question. It was more of an exam question. Right. So this is 10 marks. Easy stuff. All right, guys. So obviously, when you present the answer, the graph is going to be presented without these little things that I added. You present it clean. I was just using it as a means to an end. which we have achieved, and we can move on. Okay, so everything is nice and clean. So this is what you present, and for an easy 10 marks. Okay guys, this one was a bit tricky, but those who know what to do, this was nothing. Okay, let's get to the 3D structure. So this is question 8. So question 8 says, as part of a school project, learners are required to design a portable stage for a puppet show. As shown in the diagram below, the design must fulfill the following requirements. BKLC is a horizontal base having KB of 104 degrees and BKC of 52, so nicely indicated. So we've got those angles. Okay, so they are shown for us to use. Okay, and the rectangular backdrop ABCD is vertical to the horizontal base. It must have an area of, this is nicely indicated. Good. The sides of ABCD must be of this ratio. AB is to BC, 1 is to 2. So if we say this is X, be very careful of writing this. This must be 2X, okay? I say student wrote 1 and 2. That doesn't mean units, but X and 2X. Choose a multiple that will keep those in proportion. Otherwise, it's not exactly the size. Now, the stage must be partly enclosed with triangular sides. Okay, these are the ones. Okay, right. Nice and easy. So it says show that AB is 18 centimeters. Okay, that's not a problem. So we know that 8.1, we understand that the area of ABCD is equal to 648, isn't it? This implies that X times 2X is going to be 648. So this implies that 2x squared is equal to 648, isn't it? So this implies that x squared is, let's say 648 divided by 2 is 324. Right, we take out the square root on each side. So therefore x is indeed 18 centimeters. Right. Very easy. But don't see the 2 marks and think you're not going to show. If it says show buffet to everything. The area of a rectangle is length times breadth. So this is very important. In fact, I would mark this because the rest is easy after all. I mean, yeah, doch, what can we do? Gymnastic, whatever. This one is very difficult to mark, but it is what it is. So 8.2 says, calculate the length of AC. So AC is the diagonal of the rectangle. Okay. Okay, so we want AC, so that's not a problem. We know that we're going to work in this triangle. It's going to be a right-angled triangle. Right. So So we can say in triangle ABC, we know that AC squared is going to be equal to AB squared plus BC squared. That's from Pythagoras, so that means AC squared equals AB is x, so this is 18 squared plus BC is 2 times that becomes 36 squared. Therefore, AC is equal to square root of 18 squared plus 36 squared. This gives us 18 root 5 centimeters. Okay, sometimes you can leave it at this, but if you like, you can show it as a decimal, that AC is 40,25 centimeters. This is okay, but even leaving it like that is still okay too. Either one of the two. But don't do both, okay? If you start doing both, it means you're not sure of what you're trying to present. Okay, right. So we're getting 2 marks. The substitutions and the answer, whether it's the second one or the first one, it matters not. 8.3 says calculate the length of the diagonal KC. Now the diagonal KC is on this triangle that I outlined, whatever that color is, red or pink, whatever you will. Now the good thing is we can see there that we've got 2 angles. The angle opposite the side in question, we've got an angle opposite a known side, which we just calculated indirectly. So essentially we can just use our sine rule here. So we can just say in triangle BCK, we know that we're looking for KC, so we can say KC over the sine of the angle opposite that. So it's going to be the sine of 104 degrees is equal to essentially BC. BC is 2 into 18 all over sine of 52,6 degrees. This is the sine rule of triangles. Because it only works in triangles, isn't it? Yes, don't do it elsewhere. You're gonna die. So this implies that KC is equal to 36 times the sine of 104 degrees divided by the sine of 52,6 degrees. Therefore, KC is divided by sine of 52,6. Right, so what we get here is 43,97 centimeters. Good. All right, so this is easy. Again, 2 marks, the rule and the reason, and the final answer with the unit included. Right, so 8.4, let's see if we can squeeze it here. It says if AB is equal to BK, that makes that triangle an isosceles triangle. Calculate the size of KAC. So we want this. So the nice thing is, if we look at this big triangle, If we look at that triangle, right, okay, maybe let's not do the part. We will see that that satisfies the cosine rule. And we want the angle opposite that side we just calculated, which is this side. So we can use our cosine rule here. We can just say in triangle ACK, we know that essentially KC squared is going to be equal to AK squared. Okay, this one is going to hurt a bit. Let's just move on to the next page, because I forgot that we still need to work out AK. Okay, let's start here. 8.4. We know that in triangle ABK, let's start there. Understand that AK squared is going to be BK squared plus AB squared. From Pythagoras, this implies that AK squared is, this is 18 squared plus 18 squared. Therefore, AK is so this gives us an 18 root 2 centimeters. Okay, so that's cool. Nice and easy. And now we can go on. We can say then in triangle KAC, what is the story there? We understand that KC squared is going to be equal to AK squared plus AC squared minus 2 times AK AC times the cos of KAC. That's the cosine rule of triangles, right? So this implies that we've got KC now. We got 43, so this is 43, 43,97 squared equals AK, we just got it, it's 18 root 2 squared plus AC. What did we get? We got 18 root 5 squared minus 2 into 18 root 2 into 18 root 5. Is that so? Yowen, what are you doing? Okay. Cos of KAC. Now, folks, we know the gymnastics, so this implies that cos of KAC is going to be 43,97 all squared minus the sum of 18 root 2 squared plus 18 root 5 squared. Right. All of that divided by minus 2 into 18 root 2 into 18 root 5. Ugly lovely. Is it ugly lovely? It's an ugly expression. KAC equals the arc cos of this thing here, 43,97 squared minus, essentially we can just say 18 root 2 minus 18 root 5 squared, all divided by minus 2 into 18 root 2 into 18 root 5. Therefore, let's see, that looks like 90 degrees, slightly more, slightly less. Okay, arc cos of this one, 43,97 squared minus 18 root 2 squared minus 18 root 5 squared divided by minus 2 into 18 root 2 into 18 root 5. Okay, what do we get? Yeah, I'm happy with the answer. It looks reasonable. So that's 80,60 degrees. We could see that that is close to 90, if not 90 exactly. So getting this value very close to it, I'm happy. So again, folks, not a very difficult. In fact, this paper is feeling like an IEB paper, the way it's so easy. You all know the IEB papers are the easiest. So 10 easy marks, 10 IEB marks. Come on, guys. NSC, supposed to be hard, man. It's a national paper, that thing. Cannot be making it look like IEB papers here. What are you doing? Killing us. You're killing us. We don't want these easy things here. Because we want to teach students who are growing, not students who are just going to, what you call, regurgitate, and we all claim they're the smartest. This one is the one. Right. Writing the rule in the specific triangle, yeah. Substitution, yeah. Final mark, yeah. That should be 4 marks. Excuse me, guys. I'm a bit silly now, but let's move on. Let's do question 9. Now we get to Euclidean. I feel like also they kind of toned down on Euclidean geometry. Hate it when they tone it down like this. Of course, guys, I'm not going to do this question. It's in the book. So I'm not going to spoon feed you so much that I'm going to just repeat what is in your books. Remember, guys, before the class, I told you. I'm sure you got it nice and easy there. So 9.2 says, in the diagram, O is the center of the circle. POF is the diameter. Yes. If this is a diameter, okay, first of all, let's just do it. I just hope these are straight lines. I would be very angry if they are not. Damn it, they're not. Okay, let's leave them. Looks like whoever copied this was a bit... This diagram came out skewed. Okay, nice and easy after all. Okay, diameter, the radii are all equal. I went superb. So that means if that is 32, this should be 32 also, ne? Yeah, angles opposite equal sides. Great. And then what else? OM cuts this. Okay, MF is a tangent to the circle at F. So we know that the diameter meets the radius at 90 degrees. OM cuts the circle at L and the angle that we saw. Okay, easy stuff. Calculate with the reasons the size of, so I've got 9.2.1. Okay, we want O2, so we can clearly see there that O2 is an exterior angle of this triangle. Ne? Yes, sibonile. Alilililili. Pepeli kamanza mancinci. Thank God, guys, these examiners feel like they just gave up. They just gave up on examining. Really now? Heaven. Okay, you can use angle at center here to avoid needing to state what that angle is. At this point, we're just going to say the easiest. But you see, what I hate, folks, is this kind of a question. You see, when this question is popped, I often avoid a situation where I don't calculate, because it's very clear, calculate. But the angle at center on its own forces us to kind of perform a calculation. So maybe let's do it. So we know that O2 is equal to 2 times P. Angle at center equals 2 times angle at circle. So this implies that O2 is 2 times 32 degrees. At least this one is fine. My protest didn't work, so this is 64 degrees. At least this part signifies a calculation. Okay, fine, fair enough. 9.2.2 angle M. Okay, also angle M is not so bad, because we're going to use 3 angles of this triangle. Okay, right, so we know that in triangle OMF, right, we can say OFM is 90 degrees. Why? The tangent is always perpendicular to radius. Can say then we know that OFM plus O2 plus M equals 180 degrees. This is sum of 3 angles of a triangle. So this implies that 90 degrees plus 64 degrees plus M equals 180. Therefore, M is equal to 26 degrees. Okay, nice and easy. Okay, I'm happy. I take back my protest. Both of these required us to do calculations. That statement and the reason, substitutions, answer. Yeah. Powerful reason there, and the final answer. Okay, good. So at least for these questions, we did demonstrate some form of calculation. Of course, this is an easy 10 marks, provided the proof was done properly. I'm not gonna go into that, guys. This is not the time. So those who want to pass grade 12 Euclidean geometry from term 1 to the last, it's time to practice all the grade 11 proofs this December and get a grade 12 textbook. Remember, guys, your teachers know exactly who you are. You can even go and borrow a grade 12 textbook straight up. Use it during the December holidays to practice everything. Don't wait until next year. Take it, just borrow a grade 12 textbook. When these people are returning these, you can sign up for that one, because you will probably gonna keep it for the year. But if then there's not enough of them, just borrow it to return it in January. But make sure you sign for it, so that if you lose it, you pay for it, right? Borrow that textbook. You go and sit with this during December. There's videos on this channel. You look at videos on this channel as well. In fact, I would advise you guys to even take the past exam question papers. Take a topic by topic, okay? You know that algebra, guys, is easy. So go and challenge yourself with those algebra questions using your textbooks for a bit that takes you into those kinds of questions. You do sequences and series, you do functions, you do differential calculus. Mind you guys, by the time January comes, you would have finished the maths syllabus for grade 12. Because most of it is grade 11. Just finish exercises in the textbook. If you can, buy a study guide instead of buying Christmas clothes and drinking alcohol. Just buy a nice study guide and a textbook. The study guide I would recommend is Kevin's study guide, mathematics study guide. It says maths made ridiculously easy, something like that. Buy that study guide, you will be fine. And then you perhaps purchase a textbook if you can. Classroom mathematics is the best. All these other textbooks, I don't know about them, but classroom is perfect for students who want to master the subject. Then you sit home, guys, exhaust examples in each section for grade 12. After that, take past exam question paper straight up. Start treating topic by topic. Don't worry about doing a question paper from start to finish. Just do topic per topic and see how well you're doing. At least 3 for starters. Then after that, you can just keep jumping around and checking for challenging questions and stuff. You will be good. Come maths, term 1 exams, you're going to get 100%. Term 2, you're going to get 100%. Term 3 trials, you're going to get close to 100. 100 is not so very easy for trials. Then come the finals next year, you get 100%. You smile your way to university and do the course of your dreams. Okay, easy, folks. But again, it will take dedication to really do what I'm telling you. It's easy for me to say it, but it's not as practical as I may make it sound. So you may have to find a balance between chores at home, because remember, you are a human being. You're not just a robot. It's just going to only do study work. You're not going to be a balanced human being if you only focus on studying. But study more than you focus on other things. If there's anything you can break your study with, is doing chores at home. Then maybe some extramural activities. Sports are usually a good distraction because it keeps you physically fit and mentally focused. So in a way, it plays in the right hands of studying. So yeah, rather do those things. You'll be fine. Then you won't be crying at the end of the year. And this channel, guys, is available to you for free, okay? Please. Don't be failing maths next year and then crying about it, and yet you came across my channel, or any other channel for that matter, because all these channels are good. Now in the diagram, PQRS is a cyclic quadrilateral. Okay, we see it. All the vertices touch circumference. Since these are not nice straight lines, I'm not gonna do the things I normally do, so we can just appreciate that those points are concyclic and there's chords joining those. So that makes up a cyclic quad, okay? Then T is a point on the circle such that QT is perpendicular to SR. So this is indicated already. Then at V. Now PT and ST are drawn, okay? Q2 is 35 degrees. R is equal to S1. Okay, so this is good. We need to highlight that. So angle R is equal to S1. So what does this make? Have you ever seen an isosceles trapezium? This is the one. Because if this angle is equal to that angle, what does it mean? It means this side must be equal to this side. You see? Sometimes a question can be asked, prove that PS is equal to QR, and then start crying. How on earth if you can just prove that those angles are equal? Okay, there's a little bit more. We may have to prove that those angles are equal, provided SR is parallel to PQ, I think. For this to be an isosceles trapezium, yeah. So we may have to do more than that. But again, since we are given that this is already equal to that, our task to prove that PS is equal to QR, we would then have to prove that this is parallel to that, isn't it? But for now, it's not the case as yet. We still need to think about it. So I'm just trying to show you guys that when you actually look at a past exam question paper, you can even construct some questions that would help you to understand your craft even better. Right, anyway, it says calculate with reasons. See, instruction is very clear. We need to show a calculation. Right, the size of QTS. QTS, so this is the angle we are looking for. So what is that angle? Okay, if we look quickly, we will see that this beautiful arc subtends QTS as well as QRS. So technically, those are the angles in the same segment. So it already tells you and I that this angle is equal to angle R. So easy. So that means angle R becomes the key to this. Okay, but now angle R is in this triangle. Ne? Yamos. So angle R is in that triangle, and we can already see the exterior angle of that triangle gives us angle R nicely, and then we just go there. So first of all, we're going to say in triangle. Essentially, I may not even say this. I can just easily just go straight. I can say angle R plus angle Q2 must be equal to angle V1. This is the exterior angle of triangle QVR. Right. So this implies that angle R plus 35 degrees is equal to 90 degrees. Therefore, angle R is, let's see, 90 minus 35 is 55. Okay, so I've got a story, but I know that essentially angle QTS is equal to angle R. Why? These are angles in same segment. So therefore, QTS is 55 degrees. Nice and easy. At least we did perform a calculation. So make sure your answer, guys, has a calculation here. As much as there may be other ways, but if that other way does not involve a calculation, please don't do it. Don't do it. Once the instruction is clear, you follow the instruction. Don't bend it. You will be dead. So folks, I know that this is a powerful statement, a good conclusion. Perhaps that statement makes life a lot easier. The answer there is not important until we get to the final. Right, so 10.2 says, prove that PQ is parallel to SR. You see? Yes. Now, how are we going to do it? Whew, 3 marks. Why do I feel like I'm getting punked? I'm getting punked. Okay. I think our challenge here is to notice that this friend is equal to that friend. These are angles in same segment subtended by this arc, RT. And since we know that this is equal to that, we add this up. Remember, this forms a cyclic quad. This forms a nice cyclic quad. But these are not exactly nice straight lines, so I'm a bit unhappy with them. Okay. Okay, so that is a cyclic quad. So if we know that this is the 1 and then that is the 1, so we say this angle plus that angle, Q1. These are going to be, yes, and yes, opposite angles of a cyclic quad. If we prove that that is 90 and this is 90, we can say co-interior angles are supplementary, therefore the lines must be parallel. Okay, let's approach it that way. We're going to say, well, first of all, we know that S1 is equal to angle R and so equal to 55 degrees. This was given. And we calculated R. We can say here also, we know that angle S2 is equal to angle Q2 and so equal to 35 degrees. Now these are angles in same segment. We can say then, we know that essentially S1 plus S2 plus Q1 is equal to 180 degrees. These are the opposite angles of a cyclic quad. We need to state this one is PQTS. Okay, because all vertices of that quadrilateral hit the circumference. So this implies that S1 is 55 degrees plus S2, that's 35 degrees, plus Q1 equals 180 degrees. You can say therefore angle Q1 is 180 minus 55 minus 35 is 90. Is 90 degrees. We know that, okay, therefore we understand that Q1 plus V1 is equal to 90. Let's just do it nicely. 90 degrees plus 90 degrees, okay, which also goes on to say Q1 plus V1 are supplementary. Remember, we need to use this. They're not necessarily equal, but supplementary. You can say, therefore, PQ is indeed parallel to SR. You can say co-interior angles are supplementary. Okay. Right, so this one was easy. Very, very, very easy. I do think this is important. That statement is key. And the reason the rest is your problem, it seems. But maybe there's a very quick approach. I don't know. Because I'm thinking about it. Yeah, I kind of did more than I'm supposed to. Look, we could have used the cyclic quad that we were given. See that PSR. Already we would know this, and then this 35 plus that should have been 180. So we quickly get to this business, okay? I kind of chose a long route, which makes it look like there's a lot of marks, but there is not a lot of marks. Okay. But it's not really that much of a big deal, is it? Nah. It's quite similar. Anyway, 3 marks in the bag, folks. And now if I can tell you, we can conclude that PS is also equal to QR. Ne? Just state. We can clearly see that PQRS is an isosceles. I think that's the correct word. Isoscaline, isosceles trapezium. That one, we know that the sides opposite the equal angles must also be equal. Okay. Or one can say the sides opposite the equal angles in a quadrilateral makes that an isosceles trapezium. So these are things to think about. Okay. Please note these. You never know when you're going to need them, especially for those who are going to decide to take an upgrade. You may be punished over what I just told you and you ignored. These exams, guys, are going to horrify you. Trust me, they're becoming unpredictable. They'll make this easy and then you'll think the next exam is going to be easy and then it destroys you. So be very careful. Right, prove that PT is a diameter to the circle. It's done, isn't it? It's done. So we can just look at this situation that look S1. See, sometimes other ways look crazy, but at the end of the day, it's done. So for me, we can prove, since Q1 is 90 degrees, we can just say, well, Q1 is 90 degrees. We've proved it above. We can say, therefore, PT is a diameter of circle. Right, the reason here is that this is the converse of angle in the semicircle. Ne? Very, very, very easy, guys. They were just showering you guys with marks here. Yeah, well, 2 marks, easy, or even 2 marks for the final little thingies. So guys, we're just gifted marks in this exam. Even finishing this exam should have been easy for... come on, wena man. Skantina, wena man. Nketsa diphahlo, jwale, ebile di diphahlo tsa teng, ke tsena tse tight-nyana tsena. Yeah, nna ke tene ntho tseo. Ke motho wa ntate, e seng motho wa ntate o sa itsebeng hore o motho wa ntate kampo o etsalang ka ena. Yeah, o tseba hantle hore ke reng. Question 11. Right, it says in the diagram, triangle ABC is drawn, BA is produced to E. We know what, if something is produced, it means it's a straight line. And E and D are points on BC such that that is parallel to that, AD to EF, that we can see. And EF intersects at G, okay? AC and EF intersect at G, okay, that's fine. CF over FB. So CF over FB. Right, we are told this is 2:5. So if we say this is 2x, maybe let's write it like so. If we say 2x, then this must be 5x. Please choose this multiple. Do not take this as 2 units and 5 units. It's not. Right. And then we've got CG. CG over GA. This is 3, so if this is 3B, then this must be 2B. Again, please don't forget. Choose this multiple. Doesn't mean it was 3 units and 2 units. Okay, so this is cool. We are ready. We are ready to do the things that must to can be done. Right, 11.1.1 says calculate. Again, we need to show a calculation, guys, with reasons. FD over CF. FD over CF. Okay, what I'm seeing, see that triangle there is our way to Jerusalem. So this means we want this business and that business right there. You see, Mos? So we know that in triangle ACD, it really doesn't matter what you say, as long as we can identify the structure. We know that FD divided by CF should be the same as AG divided by CG. This is the proportionality theorem with AD parallel to GF. Please, guys, the proportionality theorem only applies when this is the case. There is a condition for it. You can't just say prop theorem and that's it. Remember, when the line is drawn from one side to the other, but it's not parallel to the third side, the proportionality theorem does not apply. So this is why we need to always state the set of the parallel lines within that triangle. So essentially this implies this is 2B divided by 3B. Then these things go away. We can say therefore FD over CF is 2 over 3. Please be systematic. Don't just look at the marks and write the answer. No? We want things. The statement and reason is important. The final answer, but we need to see that calculation. We see that calculation over there. 11.1.2. So it says we need BA. So we want BA over EA. Okay. So as we can see, guys, this one is doing something like this. It's saying to you and me, we need to use this triangle. This one must involve this green triangle. I hope these are straight lines, otherwise I'm going to be so angry if not. Okay, it looks like it, but even my surgical precision there was doing the things. Nice. So we need to use that triangle to get around. But hey, it's going to be a bit technical, okay? So this is a true exam question. Yeah. Not too bad, after all, for those who have been working with me all along. Ne? Yeah. For those who've been working with me, they know the things. Hmm. Okay, this one is a bit tricky nyana. Ngisacinga ukuthi ngizokwenza njani. Yeah. Okay, all right, okay. So I'm trying to think and to think very fast. If we use this little thingies and say this one split nicely like that. If this is 5, that is 2, then this is 3x, sorry. So this means we've got 3x there, isn't it? Yeah, so now we need to represent FD in terms of x. If we can represent FD in terms of x, we will be good. But now how will we do that? Damn it, man. This introduced yet another little thing. So we've got 2 over 3 here. CF became literally 3, let's say 3y. Okay, it's not so nicely visible. So this became 3y. And FD became 2y. Remember, those were ratios within a ratio. Now I'm thinking we need to start strategizing here to get around. We either want to showcase f, what is this? I think we want to showcase x in terms of y. I think that would be the best plan. And we know from there that we can actually use this to do that. And everything else will fall into place, because if this is 3x, if this is 3x, if we can represent that x in terms of y, we would be able to do this one. It's a bit tricky, but it is what it is, you know. So these are the kinds of questions that say, hold it, you're too fast, you're gonna crash. Now I'm gonna say, folks, well, I know that 3y, of course you will have annotated the sketch, is equal to 2x. Okay, you can just say C sketch. Remember, these are provided, the diagram sheets. So I want to represent x in terms of y. So this means that x is equal to 3 over 2y. Yep. Yeah, boy, yes. Now, if this is the case, now I'm interested in dB in terms of y, right? Yes. So this implies, okay, we can say also, once we know this, but I think I can say this implies, isn't it? It does. This implies that dB or BD, let's just say BD, plus FD is going to be equal to 3x, okay? BD is what we want, plus FD, we already know that this is 2y, this is 3x is 3 over 2y. We can say therefore BD is equal to 9 over 2y. It is. Aye, yeah, go, boy. Don't lie, see, don't be complacent. We need to subtract 2y here. Therefore, BD is 9 over 2 minus 2. It gives us a 5 over 2y. Okay, good. Okay, strategy, guys. Strategy will take you far. Now we know that. Then, in triangle BFE, now we can deal with the issues. BA over EA is going to be equal to BD over FD. Proportionality theorem with AD parallel to EF. Okay. Please use the sides in that triangle you've identified. So this implies that BA over EA is going to be BD. So BD is 5 over 2y. Right? Divided by FD, which is 2y. So this implies that BA over EA is going to be 5 over 2 y times 1 over 2 y. Right. Yes. So therefore BA over EA is going to be 5 over 4. Okay. Ne? Okay, guys, it's done, and it makes a bit of sense. BA is much bigger proportionately to that one. So, if the ratio makes sense to me, because that's the ratio that should be more than 1, and it is. So, whether we've made a meal somewhere, I don't know, but we're doing it. 4 marks, so ithathapi. Ngapayana simnandi. Statement and the reason, final answer. Everything else is your problem, my friends. You see, right. So we've got 11.1.3. It says the area of GCF, so this is this one, to GFDA, so this is the one. Can stipple it nicely. Okay, so that trapezium there. Okay, right, so again, this is one of those questions I would say higher grades, which is good for an exam. Right, so we can clearly see that, okay, that one, we have a problem. We need to use elimination. So we need to take the big triangle, subtract the small triangle to get this one. And that one is easy, but we're going to use the sine rule. So, okay, all right, okay, we're going to say, fine. Let's start by looking for the area of, but anyway, I'm just going to do it here. So I'm going to say area of triangle GCF divided by area of GFDA. This is equal to, I'm going to use the area rule. So it's half CG or GC, let's just say CG times CF. sine of angle C divided by, this one is going to be the area of this big triangle, which is half, let's just do it, it's half CA or AC times CD, the sine of angle C, minus this other one, which is half CG times CF times sine C. Okay, because that one is the area of the yellow triangle minus the area of the stripped, or is it striped? The striped one, black stripes. But now we can't cancel things yet. We need to work on our magic. So this is equal to, there's nothing we can do about the numerator. CG. Okay, maybe let's substitute instead rather than leaving it like that. So we can just easily write 0.5 into CG. CG, it's 3b, we said. No? Into CF, we're going to just use the y value. So it's going to be 3y. Ne? Yeah. 3y times sine of angle C, all divided by, we're going to have 0.5 here. AC is 5b times CD, that's 5y, right? Times sine of C minus 0.5 into CG, this is 3b, into CF, this is 3y, sine of angle C. Okay. All right. Okay, let's clean it up nicely. So we've got 0.5 into, this is 9by, this is 9by times sine C, all divided by 0.5 into 25 by sine angle C, 0.5 into 9by sine angle C. Right, so we're going to do this one, 0.5 into 9by sine angle C, all divided by, we take out the highest common factor here. The highest common factor is 0.5 by sine angle C. What remains? This is 25 minus 9. Ne? Uyabona. I-mathematics lento. Hayi mdlalo. 25 minus 9 is 16, ne? It is so. So this is 16. There's nothing more we can do here. Okay, easy stuff. Okay guys, please know your stuff, know your maths. I told you guys, even in Euclidean geometry, you'll still be doing algebra, factorizations and stuff. If you don't think about this, you will be dead. Okay, right. So yes, 4 marks, my lord. But this is good. That is good. 2 marks. Remember in maths, folks, when we factorize, that is the mark and the final answer. The rest is your problem, okay? Right, the rest is your problem. Now let's do the 11.2. With 11.2.1. It says in the diagram, WVZR is a cyclic quadrilateral. Okay. WVZR, we see you, we see you, we see you, we see you. This one. You are there, you are there, you are there, you are there. You are beautiful, you are beautiful. That is the cyclic quadrilateral, cyclic quadrilateral. RZ is produced to Q. Where is it? RZ produced straight line. A tangent is drawn from Q to touch the circle at S. This one is a tangent. Agwan, Rushebil. Damn it, man. It's not a straight line. Okay, that's the one. That's the tangent. And if we see this already, folks, we know that the 10-chord theorem is going to do us the things, okay? Nice. We don't want to wait. And what else? Let's read. WV is produced to E. Again, that's a straight line. If this is the case, this is already telling you and I that that angle must be equal to that angle, right? Exterior angle of a cyclic quad as well as that angle. Again, exterior angle of a cyclic quad, or we can say vertically opposite angles. Cool. What is the next one? Is there any more? Let's just highlight this. Okay. Right. Okay, let's just read. Okay. Now this is easy. RW is also produced meets what. That means that is becoming a straight line. And if it is a straight line, what message is it sending? Is that this angle must be equal to that angle. Again, exterior angle of a cyclic quad. Right, and then PQ is drawn parallel to WE. And what? Okay, guys, there's going to be a lot of angles that are equal. We see correspondings. We see alternate something. You see that angle and this angle. Maybe it's good to show. But yeah, let's leave it like this. Now, we're going to the business of the day. Prove with reasons that PR, where's PR? PR is this side, is equal to PW. PW is this side. QR is that side of that big triangle. Okay. And then QE. QE is that part. So we know that with this side drawn parallel to that in this triangle. Proportionality theorem straight up. So we know that PR. By the way, we revised these ratios, isn't it? PR over PW is equal to QR over QE. Ne? It's as easy as this. We know that this is the prop theorem with EW parallel to PQ in triangle PQR. So when we cross multiply that, we can see that therefore PR is equal to Q. Let's start with the PW. Done. This one is the statement and reason. This is already the things, but again you can think about the gymnastics involved, but yeah, it is simple as that. Now 11.2.2 says if triangle PQZ, this one here, is similar to triangle QRS. QRS. What? You are kidding me, are you? No, man. PQZ here and triangle RQP. Okay. So the big triangle and that triangle. We can already see that P1 through this angle is equal to that angle. So that's why they are similar. So those angles are equal. So this is given. We're not going to prove it, but we just want to know which angles are equal. That and that. That's the first pair. Second pair. Okay, Q1 is common. Yeah. So that means that angle at Z is going to be equal to that angle at P. Okay, good. We know it. So we can safely, it says we need to prove this. Now we know that PQ is the common side. So this is fine. PQ over. Now PQ in terms of, say, the small triangle, if we will, or we can say in terms of the big triangle, it doesn't matter. So PQ is opposite that angle in the smaller one. And that angle is equal to that. That side is opposite QR. So this is going to be QR. Or RQ as it is written. Is going to be equal to, now I'm going to choose that QZ straight up. QZ for the small triangle. Now QZ is opposite that angle. That angle is equal to that. The side opposite that is PQ. And we can say this is the proportional sides of given similar triangles. So when we cross multiply here, we can see that PQ squared is equal to RQ times QZ. So what was key here was the statement and reason. The gymnastics leading up to the answer. Not that big a deal, but we need to show them. Right, so we've got 11.2.3. It says we need to prove that these two triangles are similar. So QSZ is this one. Yeah. Okay, guys. Nice and easy. We don't rush. We take our time. Remember, this is a review. It's not an exam. It's a review of an exam. So don't be in a hurry. You're going to burn. And then QRS, the big one. Let's make it nice and green. But it's not going to be so nice because these are not straight lines anymore. Oops. Those who attend my classes and essentially listen when we teach them things, or those who watch videos in the channel, they already know what is cooking here. Even without proving similarity, if at all, we need to prove something. We know that the tan-sec theorem is applicable. You cannot tell me because it is not stated nicely. It's not correct to use it. Hold it, comrade. You can use it. Okay, guys, let me not talk nonsense here. Now let's just do it quickly. We can clearly see that Q2 is common. So in triangle QSZ and triangle QRS, what we know is that Q2 is common. 2, we know that angle S1 is equal to angle R2. This is the 10 chord theorem. Once you prove two sets, guys, it's done. So therefore triangle QSZ is similar to triangle QRS. Angle. The third angle is by default not a necessity to mention, to be honest. Right, this, that, and the reason for the similarity. Easy 3 marks. Now let's go to do the things. So we can say 11.2.4 says we need to prove that PQ is equal to QS. This is easy. We just need to say technically QS over QS in the small triangle is opposite Z1, but Z1 is equal to S1 plus 2 on the other one. The side opposite that is QR, or it's RQ. This is equal to, now we're going to choose strategically again, QZ over, now that is opposite S1, S1 is equal to R, and then that is QS. So these are the proportional sides of similar triangles in 11.2.3. Okay, right. Now we cross multiply here. So we can clearly see that essentially QS squared is going to be RQ times QZ. Now this concludes that PQ squared is equal to QS squared. H is equal to RQ times QZ. Now when we take the square root, remember guys, the gymnastics are not going to be forgotten, you see. Therefore we know that PQ is equal to QS. Finish and clear. Okay, that's easy. We're going for how many marks there? 3. Okay, that statement and the reason, this business, and perhaps the gymnastics here, suppose, is done. So 11.2.5, it says we need to prove that PW, which is this one, is QE times PZ. QE times PZ, okay. PZ. Okay, this one looks strangish. Where is PZ coming from? And then over the square root of QR plus QZ. Okay, so this one, it's this guy. So it's either we had a PQ squared underneath or a QS squared. It's either that or QS squared. So where's QS? QS is over here. Okay. So, which one? PQ versus QS. I think PQ. QS is not likely. It's not likely. But I think PQ is very likely. Because when I'm looking at those triangles, it looks like I am comparing this triangle as was given. I'm comparing these triangles. Yeah. It looks like these are the triangles we are using. So let's go for business. Let's go for business. Let's go for business. Now we can say, well, we know that PW over. Now if you look at PW, it's opposite that, which is equal to that. That is opposite that, so QZ is there. Hey. There's no QZ there. There's PZ. Okay. Wait a minute. Okay. Wait. PW from the small triangle. Let's start there. It's opposite that angle Z. That angle Z is equal to that. It's going to be QR. Ne? Let's start there. So this is going to be QR equals. And then we then take that. But my feeling is that the QE is going to cause me trouble. The QE and the PZ are going to cause me trouble. But let's just go for it and see what happens. And then this question, why is it trying to mess with my head now? Because you see, these ones are doing the things. Ne? Okay, let's do the PZ. Let's not worry. PZ over. Now PZ is opposite that angle, which is going to be PR on the other side. But do you see now what is happening? So I've got PZ, I've got PW, I don't have QE, I also don't have, okay, QE. But we're going to get them in, don't worry. So far, we start with what we need and we stop. So, yeah, you know what, guys? I'm feeling like some things are not doing the things. I think some things are not doing the things. And not doing the things is not allowed. Okay, but let's go for it. Sometimes it is what it is. So this is similar triangles in 11.2.2. Right. We know that PR came out to be PW times QR over QE, isn't it? Yeah. So we substitute this friend. So this implies that PW over QR is going to be equal to PZ over. This one is PW times QR over QE. Okay, let's move nice and easy. So PW over QR. This flips around, so we get QE times PZ all over PW times QR. Okay. Is the one. Okay, all right, okay. Now what must we do? We must do things. But you see now, kinale botata. Everything is coming, but not just the way. It's not coming just the way I want it. You see. It's not doing the things I want. Okay. Phanze yaphuma man. Kanti theni uyazi ngiqhela kakubi lento ekugqibeleni. Yewena suniphaphela wena man. Suniphaphela wena man. Funa undenzani. Damn. Okay. Part of me feels like I need to think hard, you see. How do I get rid of this PW? Take it. But I'm supposed to get PQ squared here. And why not PQ squared? PQ squared. Okay, maybe not squared, but just PQ there. I'm supposed to get PQ. Okay. Now what I'm gonna do, I'm just gonna multiply by QR. Okay. Remember, we force our hands here. If we do that, we get QR is equal to, we get QE times PZ over the QR goes, we get PW. But you see now what happens here is not the nice thing. If I get rid of QR, what do I do about my PW? How is PW related to this? Hayi wena kwashit teli ngathi ufuna uhlanyisa nje wena hayibo into elula kanje ngokitheni ngo ingathi iqale wrong lento. Let's just first see PW over QE. Is it possible, or PZ? PW over QE. Nah. sorry, PW over PR. Maybe I should have done this perhaps instead. PW, let's start. I think this is, I'm complicating it. PW over PR should be equal to QE over QR. Right? Proportionality theorem in that big triangle. And then what do we have? We've got so after this, what I'm trying to do, I'm gonna force it. Now if I decide to multiply, because I want PR out of here, so what I'm gonna do, I'm gonna multiply by 1 over PR on both sides. PW over PR times 1 over PR. Don't do it. Mayengangiqheli question. Mayengangiqheli. So what are we doing here? Yabani. Kanti thina lento QE and PR and over QR. QR ukhona, but kutheni ngafuna uba lento endiyifunayo kahle. Okay. Right. Even if I do this here, I'm still gonna end up where I did not want to end up. You know. Hey, this question. Yawana. Hey, unketha. Okay, masike siqale ekuqaleni. Khona into endingayivisisisi kahle. Masike sithi kanje uPW. Hayi man, kodwa uPW kuzabe khona funeka vele phaya man. It's not working man. That's PW is not coming out. And in my mind I'm looking at PQ. Okay, all right, okay. Masike sithi PQ over is equal to PR over PZ. We don't know PZ, do we? Eish guys, tell me the question. Best cruiser kamnandi kanga. Vela nje into snacks ngoku ekugqibeleni. Mangavela into snacks la. But you see, we're almost done. bafethu. Oh, PZ ukhona konje. Hayi man, wenze ba stupid kanti ngoku basesibhanqa wena man. Phela kabi. Itheni wefuna undiqhela ngoku mayingandiqheli kaloku mayingandiqheli. So izawuphuma ngoku iyaxoka noba seyithanda iphumile nje. We do this QZ times the things, so it's going to have cross multiplicity there. So we end up with PQ times PZ equals PR times QZ. Ne? Yeah. So now I know. OPZ is there. But iwari yam lo PQ kutheni ezovela apha ngoku. Akafanelanga uvela phayana. You know, that PQ is not supposed to show up there. But let's first do this. PQ times PZ. PR is PW times QR over QE times QZ. Right. So we've got PQ plus PZ is equal to PW times QR times QZ over QE. Right. Now, masesime kanje. Multiply there. So we're going to get PQ times PZ times QE equals, so we divide these by QR times QZ equals PW. Now PQ, this is basically PQ times PZ times QE over, this is basically PQ squared from above. Then that takes the square. Ngiqhele kabi. Ngiqhela lawe mos. Yare doch mos. Ingijwayela kabi iphumile. Okay. But it's a bit of a flip and flop. It's a true suplex. I actually looked down on this question. Okay guys, sometimes when you get stuck, you try it out. So we can clearly see what we needed to do here. We just take our PQ over QZ. So I'm using these triangles. PQ, right, is essentially opposite that angle, and that angle like that, it becomes QZ. Right, this becomes equal to PR, over, now PR, opposite that angle is common, so that side PZ. Okay, so this is similar triangles in, what was that one? This one, 11.2.2. So we're using those triangles, RQP and PQZ. Now, all we need to do is just cross multiply. And then what are we going to get? We get PQ times PZ is equal to PR times QZ. Yes. This implies that PQ there's something in my ceiling, eh? I think it's a mice. It's a mouse. Kunempuku up. Now PR, folks, we take what we have there. So PR, we're going to have PW times QR all over QE times QZ. We work our magic nicely. So PQ times PZ equals PW times QR times QZ all over QE. Sometimes some questions are going to require you to just keep playing flip-flop. But maybe, I should have just put PR before my cross multiplication. I'm thinking about it because, you see, needing to do it the second time around doesn't sound so clean, is it? It's not so clean. It's only nice when you just do it the one time. But flip-flopping, folks, is maths, isn't it? But see, Provilia Spana, God, let's not rush. So this implies that PQ, just to avoid, going like crazy. So PR here is PW times QR over QE divided by PZ. Right, so this implies that we've got PQ over QZ equals, now this is going to be PW times QR over QE times PZ. That simplifies to that. I think this is now the best time to do our gymnastics of cross multiplication. Yeah, man. I think so. So this implies that we want PW to be on this side. QR times QZ is equal to PQ times QE times PZ is on. Then we divide by the things that we don't want. QR times QZ, QR times QZ. So this does the thing. So we know that PW becomes PQ times QE times PZ, all divided by, we know that from above this is this one. Yeah. So this becomes PQ squared. Then that takes the square. PW is going to be QE times PZ divided by PQ. You can say therefore PW is QE times PZ over, now PQ again, we say PQ squared is going to be equal to You know, we just take the square root there. So PQ is nothing but the square root. The question, whether you are low-key killer. I thought you were easy, man. I took it lightly. As you can see, folks, sometimes when things don't work out, you change the strategy, and then of course you try to make it nice and clean as you go along. As you can see, that was a low-key killer. I kind of overlooked it, seeing the questions were too simple. And that one was not so obvious. Otherwise, we've done it, folks, and I hope you have enjoyed the review. So I think here, main thing is this, the substitution. This PR, you see, substituting that's a mark. And then eventually, guys, there's a lot, but it is what it is, eh? There's nothing you can do. There is nothing you can do there. The review is over. I thought we were gonna finish quickly, but yeah, the last question got me hanging unexpectedly. Otherwise, folks, I think our job is done here, and I hope you've enjoyed the video and that you've learned. And as you can see, sometimes the questions may look so easy that you get misled to thinking that they are all easy. And you end up where you don't want to be. So it is what it is. I'm sure students did manage this one. If not, it's okay. It's one of those questions. Please, guys, leave a thumbs up, subscribe to this channel, even if you're not gonna need it next year. You never know. That's one thing I can tell you. You may think you're done with maths, grade 12. You may think so because you're getting into a degree that perhaps you think you're not going to need this. You will be surprised. Even if you don't, somewhere along the way, you're going to have or meet someone who needs help. Sometimes maybe a friend of yours at university might just tell you about their sibling who's struggling with maths. If you've subscribed to this channel, you're going to be abreast to what is happening in this channel. You might actually offer them some help, you know. At the same time, there may be someone who's looking up to you who you may need to assist physically or directly. You can come for ideas in this channel and check them out. So if you are still up to date with what I'm doing, it becomes effortless to extend a hand to a friend who needs your hand rather than mine. But you can come and grab my hand indirectly through you, give it to the other person. So remember, guys, connections are what makes us succeed. Disconnection is what makes us strangers. Okay, so let's keep this coherent society of people. We may not know each other physically, but we definitely do know each other through this social media business. And let us take the advantage of this thing instead of doing the opposite that I see happening all around us. Nonetheless, guys, good luck into your careers that you are going to definitely qualify for. Seeing that this paper was largely standard grade. Yeah, this paper was largely standard grade, honestly. Even they toned down on Euclidean. I'm not happy. Euclidean is not supposed to be easy, guys, please. Why are you taking the respect that this section has earned? This section is difficult, especially higher grade questions. We can't have a Euclidean geometry that is so watered down. Nah. Yeah, the last question is a bit, but I feel like most of the questions were too easy. It can't be. It can't be. Trigonometry also, I mean, it's supposed to be a challenging section, but I don't see any here. Analytical, I also don't see any. Perhaps the circle question 4.2 is the only one that looks scary. And question 3, maybe 3.5, is quite challenging, including 3.6, not so bad. I mean, the rest was just a walk in a park. Not typical of Maths Paper 2 exam, especially in the finals. But again, I guess you guys were better prepared, because there are some who are going to cry about this because they were not so prepared, or they were poorly prepared, or not prepared at all. All right, folks, that is my inputs on this paper. So the next one is going to be the physical science paper 1. Please, if any one of you has the physical science paper 2, email it to me. Use the description of this channel. There is my email address, or you can send it through my WhatsApp. That number you see there is WhatsApp. So, and that number, by the way, is the number that I use. I don't have any other number that I use. So if any one of you needs something, maybe an idea about a question or something, you're a teacher, a tutor, a student, you can call me on that number. All right, I will answer. But if I didn't answer, don't take offense. I'm a busy man, okay? I may be in theater. I take long hours operating. So the reality is I may not be so readily available in terms of answering a phone call. But a WhatsApp message, definitely the next moment I get a chance to respond, I do. Okay, so yeah. That's it for me, guys. From me to you. Otherwise, take care over the holidays. Don't get hurt. Remember, you still have a country mile to finish, meaning your career choice that you're going to make. It's going to take you to your death or your dying day. So please prepare. Gone are the days of spoon feeding. This is perhaps the last time you got spoon fed, because at university you're not. Yeah. Go and deal with the issues there and become a better individual. Who knows? You might be the person we're looking for to change this country for good. Remember, we have to keep believing, guys. It will take the ones that we don't notice to make a difference that we need. Because the ones that we think are going to make it are probably going to crumble. It always happens. Life is a mixture of ups and downs. So don't think since you've made it through matric, you're going to flourish elsewhere. No. Yes, you may and may not. Key is to find that balance which helps you to progress nonetheless. There will be moments when you're going to make a fast and quick progress. There will be moments when it becomes slow and tedious. As long as it is progress. One thing you should fight is to find yourself standing still or sliding backward. That, my friend, is not good, and it's not allowed in life. Goodbye, guys. I'll see you in the next video. It's going to be physical science paper 1. As I said, if you've got a physical science paper 2, November 2025, send it to me through WhatsApp or email, which you will find in the description of this channel. All right, let's see each other next time. Bye-bye.